Hello class, welcome to this video on lesson 2.2. We're going to go over the homework problems from Canvas, the practice quiz set of questions. And this lesson is all about scatter plots to show the relationship between two quantitative variables. Let's start with the first one. So the first one is as the scatter plot shows the percent of high school graduates in each state who took the SAT and the state's mean SAT math score in a recent year. Determine the response variable and where it belongs on the scatter plot. So we have a scatter plot. They don't label the x or the y axis for us. They actually want us to determine where they go, essentially. So in this case, the response variable, remember, so the explanatory variable is the variable that helps explain or predict the other variable, right? And the response variable is the variable that is the outcome. So basically, it responds to the change in the explanatory. So which one helps predict the other one? Let's do that first. So in this case, they're thinking that in this case, that if, for example, you have more high school graduates that take the SAT, because they're talking about high school graduates here. They're saying that the more high school graduates you take who take the SAT, then that will affect whether or not the SAT math score changes. So they're thinking that the level of high school graduates taking it is going to affect the SAT's score. Okay, so in this case, the percent of high school graduates is going to represent the explanatory variables, and that's what this x-axis represents. So this right here is my explanatory, and this goes on the x-axis. And so if the percent of high school graduates increases, it looks like the SAT score decreases. That's what it looks like here based off of this pattern. As the percent of these guys that take it increases, the score looks like it's going down, right, overall. And so the response variable is the SAT score, right? That's the thing that's the outcome of this experiment. And so this SAT score is the response variable. And the response variable usually goes on the y-axis, okay? So this is going to be the percent of high school graduates. That's the SAT math score. So the response variable here is the SAT score, the mean SAT score, and this belongs in the y-axis. Okay, they may ask us a question and go back to this in a little bit. So at least we'll have the background, the foundation laid out. The scatter plot shows data on several roller coasters that were opened in a recent year. It displays the relationship between height and maximum speed for several of these roller coasters. Describe the relationship between these two variables. So in this case, the explanatory variable is the height. They're thinking that the higher the roller coaster, maybe the faster the speed, right? The greater the speed. And so that looks like what's happening here. It looks like the greater the height, the greater the maximum speed, which kind of makes sense, right? So that looks like there's an overall pattern going on here. And we want to describe that pattern, okay? So clearly there looks to be a positive association between height and maximum speed. The taller roller coasters tend to have greater maximum speed. And for the form, so what's the form? There looks like there is a linear pattern to this. Okay, so we're going to say that there is a linear pattern in the scatter plot. Strength. How strong is it? Well, it looks like the points vary somewhat from the point. So the points vary somewhat from the linear pattern. And so because they vary somewhat, they vary a little bit. So we'll say that they vary some from the pattern, but they don't vary too much, right? So the points vary somewhat from the pattern. So in this case, they're not a strong association. It's a moderate association. It's moderate strength. It's a pretty good pattern, but it's not strong, right? It's like in between. So we'll say that there is a moderate strength association. Outliers. Are there any outliers in this data set? when you're looking at outliers, you need to see, are there points that are so far away from this pattern that it's ridiculously away from this pattern, right? We just want to see, is it really far away from this pattern? And there are no points that are striking that makes me think that they're an outlier. This one's a little bit farther away from the line, but it's not terribly far away from the line. So if you had a point that was maybe, like this or something like that, that is pretty far away from that line. Because look, most of the lines cluster around here. This would be very far away from that cluster of points, right? And so if you had a point here, then yes, that would probably be an outlier. But here, there doesn't seem to be any blatantly obvious outliers. And so we're going to say there appears to be no individuals that depart from the overall pattern. Okay, so let's look at the next question. You have a scatter plot, and then you want to match it to the association. So looking at the scatter plot, it looks to be that there's a negative pattern going on here as it's going downward. And it seems to be a pretty decent strength, right? So it's definitely not weak, right? But so it's definitely not weak, but it's definitely not incredibly strong, right? I mean, the points are clustered pretty well, but some of these points are far away, right? Some of them are. And so we'll say that this is a moderate strength. So this looks like it's a linear pattern for sure. So we're looking at a linear pattern, negative and moderate. So it looks like we'll match this up with that one. Okay. Okay, so now the next one looks like it does trend downward. However, it looks very weak. The points are so far apart from each other and from this line that we can kind of see more or less. So this is a weak negative linear association. Definitely weak. Now the one after it, this one, there doesn't seem to be a pattern, right? You can see a constant pattern. Some people see a constant pattern. Some people see this pattern, this pattern. There is not really one pattern that you can agree on. And that's because the points are randomly scattered throughout. And so therefore we say that there is no association. So this is saying that there's no association whatsoever. No rhyme or reason to any of those variables when they change. Okay, so now this one looks pretty good. It's definitely negative, and it's definitely stronger than this one. So we can for sure say that this is a strong negative linear association. So it matches up to here. This one looks like similarly is a strong positive linear association. This one looks pretty. This one looks positive, but it looks weak. It doesn't look very strong, right? So we'll go ahead and I'll call that a weak positive linear association. And this doesn't even look like a line at all. This looks like a curve, right? And it looks like the points are vary somewhat from it. So we'll call it moderate strength. And it's definitely not linear, so it's non-linear. So we can go ahead and say that this is a moderate nonlinear association. Okay, let's look at the next problem. So the scatter plot shows the percent of high school graduates in each state. So this is like the SAT example that we looked at earlier. And we said the SAT went here, right? The SAT score. And we said that the percent of high school graduates went here. Okay, so here they want us to determine the direction, describe the relationship in the scatter plot. Definitely looks like there's a negative relationship here. So we're going to say that there is a negative direction, negative association between percent taking SAT and the mean math score. So it looks like states with a higher percentage of graduates that take the ACT or the SAT tended to have lower mean math scores, interestingly enough. So I guess the more people that ended up taking it tended to mess up the average overall. So it says here the form. So is it linear or nonlinear? Well, clearly It looks like a linear pattern. It looks like a linear trend that I drew here. Strength. The points vary. Do vary somewhat from the pattern. So this will determine the strength. Okay, so we'll say that the points vary somewhat from the pattern. So there is a moderate association between those. Outliers, there appears to be, if you look at this, there doesn't appear to be any blatant outliers from this. You could argue maybe this one is far away, but really it's not that far away. But so you could say that is potentially one. However, it doesn't seem alarming if you're looking at the pattern. So like the overall, the linear trend, if you were to draw a line of what we call a line of best fit, we'll actually calculate how to do that later on, but it doesn't seem to be far away from that. So we're going to say that there are no blatant outliers here. All right, so let's look at the next one. 9th grade students at the Webb schools go on a backpacking trip each fall. Students are dividing into hiking groups of size 8 by selecting names from a hat. Before leaving, the students and their backpacks are weighed. The data here are from a group of hikers that one of the authors accompanied. Construct a scatter plot relating the backpack weight to the body weight. So here we want to construct a scatter plot because there are two quantitative variables. So these are quantitative because they involve something that is measured, and you can take the average of the numbers, and the average would make sense here. So definitely a scatter plot. However, we need to determine which one is the x-axis, which one's the y-axis, which one is explanatory, which one's response. So in this case, you can kind of think of the backpack weight as helping you predict, or rather, you can think of the body weight as helping you predict backpack weight that they'll be able to lift, essentially. So they're thinking that the school of thought is if you have an increase in body weight, so if you're heavier, you might be able to lift more, right? And so they're saying that, well, if you're heavier, you might be able to carry more on your back, okay? And so this body weight could be considered an explanatory variable. It could help predict the backpack weight. And so this would go on the x-axis, the body weight. So we're looking for things that are on the x-axis, and it looks like body weight is on the x-axis for all of them, except for these two, right? So it's definitely not going to be those two for your answers. Okay, so then we have to, basically we're narrowing it down between these two. And so we just got to determine, do the points make sense here? So we know the backpack weight is on the y-axis, and it looks like here they went ahead and they went by ones starting at 23. Same here, they went by ones. So we got to see if the points make sense. So if this is x, this is y, then these are coordinates, right? 120, 120, and 26. So when x is 120, y is 26. So when x is 120, y is 26. So that point would make sense right there. 187 and 30. 187 is around here, and 30. So that makes sense too. 109 and 26. Looks like that one. 103, 24. Like that one. 131, 29. And we'll go ahead and verify all these points are good. $158, 31. 16, 28. Okay, so that looks really good. All these check out. Now, if you look at this other one, this looks like 130 something and 35. So do we have anything like that? 35 and 165, but not 135, right? So that definitely is messing up the points. So some of these points on this one are wrong. And so therefore we got our or correct scatter plot. All right, so identify the explanatory variable for the following relationships if possible. Explain your reasoning. So the yield of corn in bushels per acre and the amount of rain in the growing season. So the explanatory variable, remember, explains the other one. So which one explains the other one? So it looks like the amount of rain could help explain how much corn you get. So maybe the more rain you get, the more corn you end up getting per acre. Okay, so if you're in a drought season, you may not get much corn. So we're thinking that the amount of rain is the explanatory variable that helps explain changes in the yield of corn. Okay, so explanatory variable is the amount of rain because it helps predict or explain the yield of corn. Identify the explanatory variable like we did before, amount of time studying for a statistics exam and the grade on the exam. So we're thinking that more time you spend studying for an exam, the greater the grade on your exam. Okay, so we could help. So studying for an exam could help predict whether you perform well on the exam or not. Okay, so the explanatory variable is the amount of time that you study. If you don't study for an exam, well, then you're probably not going to do well if you're not studying, right? So this is just kind of showing the explanation for that. All right, class, so that is it for the video. I hope you found this useful. I hope you took a couple of things from this. And as usual, I'll see you in the next one.